Hopefully that's up now. So today I'm just going to be giving a very brief overview of the surface geochemistry data that's available from Geoscience Australia. So to start with, I'll just cover our new portal, which is the Exploring for the Future portal, where all of this data can be got from. Obviously, I'm not game enough to try and do a live demonstration over Zoom, so I've just taken a few screenshots just so you can get an idea of what's available in the portal. So I've brought up Queensland here to show all the inorganic geochemistry samples that we have available. So the left-hand side of the portal there shows that we have inorganic geochemistry available, but also any hydrochemistry and organic geochemistry. So all of those can be brought in. And we can also color up each of these points in order to an element of our choice. So in this case, I've just shown the sum of rare earth elements for sediments. So you can filter each of the samples, in this case for sediments, and I've removed any rocks and seismic samples that were collected. But you can also then select different surveys or color them up by survey and then download them. So all of our data will be available through this portal. However, it's still in development. So a few of the tools are still under development and not working fully yet, but they'll be there shortly. There's also a few other tools in here that might be of interest. Our economic fairways and mineral potential mapper are also available as part of this portal. Now to move on to the actual geochemical surveys. I'll start off with our most recently collected survey, which is the Northern Australia Geochemical Survey, or NAGS for short. Now, for each of these surveys, I put up the link to where you can get all the reports from that go through in detail for each of the surveys here. But in this case, I'll give a very brief overview so you get a flavor of each one of them. So NAGS is our latest regional scale low density overbank sediment survey. So the image on the right-hand side there shows the sample locations with each of the catchments that the samples represent. So obviously, as you can see there, a lot of the samples are located in the Northern Territory. However, we still have a fair number of samples that span into Queensland and particularly north of Mount Isa. Now, for the entire area, we have 780 samples, with each one of these representing a catchment of roughly 500 square kilometres. Now, being an overbank sediment survey, it sampled the overbanks in most cases. However, in cases such as west of Tennant Creek, where we get into desert country, either the topographic low or the swales or dunes were sampled in order to try and get a representative sample for those areas. Now, only the top 10 centimetres of material has been collected in this case, which differs from some of our other surveys historically. This was mainly due to land access requirements and time spent on the ground. But we did manage still to collect a duplicate every 10th site in order to assure quality of the data. Now all the field methodology followed that of the NGSA, or the National Geochemical Survey of Australia. So the two followed the exact same methodology, so they're comparable. Now for this survey, as well as all the other surveys that I'm going to present on, we have 3 different digestion techniques available, those being total digestion, so digestion by hydrofluoric and nitric acid of a glass bead, and ecoregia digestion. And these two were performed on a coarse size fraction, a less than 2 millimeter, and a fine fraction, which was less than 75 microns. We also undertook mobile metal ion analysis, or MMI, which is a weak ionic leach technique. And this was only really done for the coarse fraction, so that less than 2 millimeters. So overall, we've got 5 different data sets available for NAGS. And following on from this, we undertook rigorous QA/QC in order to determine, 1, which elements could be used in combination for more advanced statistical analysis, and then secondly, whether each element could be viewed individually. Now, the data is available in both the raw form as well as the QAQ dataset form. So if you don't want to do your own QA/QC, and you want to just read the report to find out what we've done and what cutoffs we used, you can also just download that QA/QC version of the data. Now, we also undertook imputation on the data using a k-nearest neighbor approach, and this was just to approximate values that were less than the lower limit of detection, and that's primarily for when we undertake things such as principal component analysis, so we don't bias the results by having half detection limits. And then we also performed a centered log ratio transform in order to open the data to remove any spurious results. And then finally perform principal component analysis on the data, primarily as a data dimensionality reduction tool in order to have a first pass view of any patterns and associations between the elements in the region. Now, all of these are available as PDF maps associated with the data reports, and all the data associated with principal components and these CLR transform are also available, and that's the link there. But you can also just Google Geoscience Australia and NAGS, and that should bring you to that page as well. We've also been doing some machine learning work with this data set. In this case, we've used a combination of NAGS, the National Geochemical Survey of Australia, as well as some historic samples from Headley's Creek, Seagull, and the Mammoth Mine map sheets, which you can see in those dark black boxes there, where those historic surveys are. And we're using this as a method to try and determine the environmental baseline between each of our sample points, and then use this as a potential method to detect geochemical anomalies. Now, this will be outlined further in an extended abstract, which will be coming out shortly as part of Exploring for the Future. Next up is our national geochemical data set, the NGSA, with this covering 91% of the continent. And as you can see there, the majority of Queensland is covered by the survey. Now, as I mentioned, NAGS followed the same methodology as the NGSA. So the NGSA has several reports associated that covers all the field methodologies, the QA/QC, and all the data that's available, as well as the maps. The main difference between the two in this case is the scale, with the NGSA having a larger catchment size of roughly one site per 5,500 square kilometers. And that second sampling depth, in this case, a second sample was taken at approximately 60 to 80 centimeters as well, to try and provide an overview of those bottom overbank sediments as well. And finally, of the recently collected surveys, we have the Southern Thompson Geochemical Survey. This covers both Queensland and New South Wales and was performed in two different field campaigns. So the ones of interest for Queensland are this northern section here, which was collected in 2013, and we had 41 samples for this region. So it's not a large number of samples, but again, we've got very similar methodologies to the prior two surveys, with them being overbank sediments, and in this case, again, two sample depths, that top 0 to 10 centimeters, as well as a deeper 60 to 90 centimeter interval. Now, both the Southern Thompson and the NGSA also contain the three different digestions, so that total digestion, acarrhea, and MMI. So all of those are available from the GA website, as well as the raw data through the portal. I'll just cover on some ongoing work that should hopefully be released before the end of financial year. In this case, it's our large-scale leveling program, where we're looking at current and historical surveys in order to create a seamless geochemical data set for the North Australia Kraton. So in this case, we've only taken those top sediments, that 0 to 10 centimeter interval, and only the total digestion and fine fraction. So this is primarily a less than 75 micron fraction, with some less than 180 micron fractions also in there. It's also representing different sampling medium, so stream sediments, overbank sediments, as well as colluvium and others. So a large number of these samples are located in Queensland, so primarily in that Georgetown, Cape York region, with over 8,500 samples available in that area. So that's over half of what's going to be available in the data set, which is made up of just under 16,500 samples. Just to give you an idea, of where these samples are located. I just brought this map up here. So as you can see, we've got very high density along Cape York and then going down into Georgetown. These samples over here are in the olive color are the Headley, Seagull and Mammoth Mine map sheet samples. So we've got about 4,000 samples there as well. So we really do have some high density data there that should be available through the portal coming up towards the end of the financial year. And an overview will be presented in another Exploring for the Future extended abstract, which again should be coming out towards the end of the financial year again. And in this case, it's overlaying on some preliminary machine learning work for the whole North Australia Kraton. So really trying to bring all this data together, to provide a seamless picture for Northern Australia. Just a quick overview of what was done to this data, so you get a feel for what's there. It was a twofold approach to leveling the data. The first was using the standards that have been analyzed with each of these surveys, and then comparing the distribution of the results in order to determine, one, whether leveling needs to occur, and then two, what kind of correction factor was required. So that top right figure there shows, in this case, calcium between a group of samples that we reanalyzed and ran in order to level to and the NGSA. And we can see there, despite there being only a slight difference between the actual median results between the two, they're very distinct populations, and that's going to be drawn out when we look at these samples together. And then secondly, we also use linear regression. So we reanalyzed a lot of these legacy samples in order to compare them, the original results with the rerun, to see how easy it would be to level them, and also whether it'd be actually applicable to it at all. So as you can see here in that bottom plot, it's the rerun samples for the Headley, Seagull, Mammoth Mines mapsheet areas against the originals. And as you can see, we've got a very good correlation between the two, which is very reassuring considering those samples were originally collected and analyzed in the 1980s. So we're still seeing a good linearity between the two, which means that we can apply leveling. All of this is covered further in the extended abstract, which will be available shortly. And just to conclude, all of this data is going to be available through the EFDF portal. In this case, it's the raw data, so none of the QA/QC information or that principal component or transform data will be available there. But if you'd like that, that's available with each of the reports, and you can download each of these surveys individually. So for Queensland, the main surveys that we have are the NGSA, NAGS, and Thompson, with each of these having 3 different digestions available, as well as 2 different size fractions. And coming shortly should be the level data set for the North Australia Kraton. Again, this will be through the portal. So that's all I have. Thank you very much.
Well, thanks, Phil. I guess it's the first time we've run a webinar with multiple speakers. So if anyone has any questions, we can take those now for Phil, or we can hold off till the end of the seminar. We haven't had any come through the Q&A function. So if you do have anything you'd like to ask for Phil, you can write that in there in the Q&A function at the bottom of your screens, and we can address those at the end. Otherwise, I will hand over to Dominic Brown from the Geological Survey of Queensland.
Can I ask just one quick question?
Sure.
I'm not, panelists aren't allowed to type in the Q&A, so I thought I'd better ask instead. And I see somebody's raised their hand as well. Phil, with the really broadly spaced geochemical data,
yep,
what do you see as the main sort of exploration application for that data for Northwest Mineral Province explorers? Is it sort of as a baseline for their more detailed data sets, or yeah, I'm just interested to hear what your thoughts were on that.
So I guess what we see our regional surveys being is trying to establish that geochemical baseline to where you can compare your samples against. So using those regional scale surveys to aid you with your high density work in order to determine whether the anomalous results are seen are potentially related to something of interest, or it's just due to the particular lithology that's being sampled. I guess that's mainly where that work would come in.
Okay, we also have a question from Mike Whitbread. Phil, what method did you favour of the analytical methods for the overbank work?
We haven't really favoured any. So we have been doing a lot of work with the total digestion, mainly because that's providing the most holistic view of the sediment. But historically, we've also looked a lot at the MMI work in order to try and use that to detect faint signals of mineral systems. So I guess they each have their place. That's why we analyze all of them.
Okay, and Ian, oh, we're getting lots of questions now. All right, we'll just take two more, and then we'll move on to Dom, and we can answer some more at the end of the session. Can you put the contact details up again, please, so we can put that in the chat stream or share your screen, Phil?
Yep. And I'm not sure I've got my contact details in there. Hang on.
You could also just type them into the chat and send them directly to Ian if you wanted to, or send them to everyone if you wanted to.
Yeah, I'll type them in the chat. I think that's probably the easiest way. Then that way people can copy and paste them as necessary.
All right, and then the last question here is, how does a stream sediment sample differ from an overbank sample in terms of how you would interpret the data?
So I guess there's a lot of questions you've got to ask about your sample. Obviously, a stream sediment is potentially going to have fresh material, and you're going to have a range of grain sizes in there. Considering it's that constant washing of material that's coming down versus an overbank sediment, which is that floodplain sediment that you're collecting. So I guess you've got to consider the mineralogy of what's going on in each of those samples, as well as how close they are to the source. So a lot of international work has shown that the overbank sediments, at least, can be very representative of large areas. I'm not so certain about stream sediments, how representative they are of particular large areas. Yeah. So I guess if you wanted more information about the source rock that's particularly feeding into the stream, then you could go that route. Or if you wanted a more holistic picture, you could go overbank, because that's collecting